I won't take us too much into your break, which is, wait, is the break next, Andy? Yeah, okay. So I'm going to be talking about data center management with Apache Mesos. So I'm just going to jump right in. So this is going to be our friend through the talk. He's going to ask us a bunch of questions to kind of take us through the story of data center management and using Apache Mesos. So a lot of you are probably thinking, yep, I want to do big data. I've got tons of data, right? And in fact, I've got more and more data every day, and this is a great thing. That's probably why they call it a data center, to store all my data. That was a joke. Perfect. Okay, and I'd love to answer some questions with the help of my data. So what can I do? All right, so the first thing you might be thinking is, all right, I think I'll try Hadoop, which is a very, very reasonable approach. So this is your data center, all 9 machines. These are 1U boxes. We're going to use this graphic throughout. Hopefully it will be self-explanatory to everybody. And this is your data center on Hadoop, plus Hadoop. All right, are we happy? Well, not exactly. Hadoop's a big hammer. It's a very, very big hammer. It can do a lot. But unfortunately, not everything is a nail. And as you'll find out about in some of the upcoming talks, there are certain things you might want to program, analytics applications, algorithms, that don't work great in Hadoop. In particular, there are things like iterative algorithms, and for that, you might want to try something like Spark. Cool. This is fun. This is part of being a computer scientist running new software. This is fun. So this enters data center management. So we'd previously deployed Hadoop on our data center, on our cluster. What's our next step? Well, we can uninstall Hadoop on some nodes. We can install Spark on those nodes. Now we're running Spark. This is what we like to call static partitioning. And in other talks I give, I typically say static partitioning is considered harmful. So, well, why is that? Well, first, it's quite possible that Spark actually wants to read and write data to HDFS. So what's HDFS? Well, as Jan was mentioning earlier, HDFS is that lower level storage layer. The right way to think about Hadoop is it's really 2 parts, MapReduce and the distributed file system. I'm going to use throughout the rest of the talk the Hadoop blue graphic to mean MapReduce and HDFS graphic to mean the distributed file system. Okay. So really, when you think about HDFS, this is more what your data center looks like. You're writing Hadoop and HDFS on the same nodes. You're writing Spark on the other nodes. So the problem when Spark wants to be able to communicate with HDFS is it's going to have to go to these other machines to actually read HDFS. It's never actually going to have any HDFS local data to get better performance when it wants to read from disk. Okay, so this is unfortunate. We could imagine, though, that we could just give Spark its own HDFS cluster too. Sure, we can go ahead and do that. Now, it's possible that the first way that we tried to do something like this was we kind of separated out like this. We really have 2 HDFS clusters. We ran HDFS on the same nodes as Spark. We ran HDFS on the same nodes as Hadoop, but they're really 2 different HDFS clusters. This is easy to set up, to statically partition at the start, but unfortunately it means that as we get all that new incoming data that I mentioned at the beginning of the talk, we're really going to have to tee this data and split it out in 2 copies to the HDFS clusters if we want to make sure that we can run computations in both frameworks on the same. And these frameworks are going to be actually writing data as well, so if we want both frameworks to be able to share the data, we're going to have to be doing periodic copies or syncs. Okay, so this is annoying. We probably don't want to do that. And can we do any better? Well, we might be able to do a little bit better. We could at least maybe start with the idea that HDFS is one big cluster running across all the nodes in our data centers, and then just do the static partitioning on top of that. So this is one big HDFS cluster, and then static partitioning of just our frameworks, Hadoop and Spark. So it's still kind of a pain in the butt, but it's kind of taking us in a bit of a nicer direction to do some of the things that we want to do. All right. Are we happy now? Well, no. We're still not happy because now we've decided that, well, we like all this analytics stuff. It's helping to support our business, and we want to start doing some real-time computation. We'd like to try out Storm. All right, so we're back to data center management and static partitioning. Except this time, we're going to swap some of the boxes or add some more boxes. Whatever we do, we're going to run Storm on its own static partition. This is not Storm's logo. I don't think Storm has a logo. I found this logo in a talk, and it seemed like kind of a cool logo for Storm. So it's Storm's logo throughout the rest of the talk. All right, well, are we happy now? Not really. During the day, it'd be nice if we could give more machines to one framework, and at the night, give other machines to other frameworks. Spark's very interactive. The way that a lot of people use Spark is with the Spark shell, which is a command line interface to ask interactive queries. You get a lot more people during 9 to 5 asking those queries, but at night you might just be running a bunch of batch Hadoop jobs. So back to data center management, it could be that sometimes of the day you'd like to statically partition like this. Sometimes of the day you'd like to statically partition like this, maybe sometimes like this, or heck, even sometimes like this. Really what's happening here is if you were to look at the resource consumption of the jobs in your cluster, over time, you have these gaps. And that's unfortunate because you could be increasing performance and reducing latency if we could actually take advantage of those gaps. On top of that, failures happen in data centers, and they require more data center management. Machines fail, entire racks fail, and sometimes you're left without being able to run your processing framework because of the fact that you statically partitioned. You'll have to come around later if you want to make sure this stuff keeps running and reallocate. Okay, so this takes our friend here from rather sober to rather unhappy to just frustrated all the time you spend doing this stuff to just downright sad. Most people don't want to deal with this. At the end of the day, a lot of us just want to write our applications, do our analytics, and not have to deal with a lot of this data center management stuff. My guess is most of you from the audience are not actually ops people. You're higher level programmers, users. Yeah, okay. So the data center, as we like to think of it today, kind of looks like this. But rather than actually thinking about the data center like this, what if we could think about it like this? The data center is really just one big computer. You have your applications on top, you have a big pool of resources, and your file system. And this again should look a lot like Jan's slide where he showed the storage layers, the resource management, and your apps on top. You have a data center computer. Now, in order to actually realize this illusion, we need something to actually do this, and you solve all problems in computer science with a level of indirection, and that level of indirection is Mesos. So rather than applications directly being statically partitioned and run across some fixed pool of machines, the applications interface with Mesos itself. Mesos acts as the kernel to this data center computer to share the resources amongst the applications, and the file system continues to live there. Okay, so how does this work? Well, let's start from the bottom up. So we start with HDFS. That's our file system. The bare bones, we can imagine putting HDFS across our entire data center, our entire cluster. That's your file system for your data center computer. Then we're going to Mesosify the data center. This is the one distributed system that you'll install to run the rest of your systems. So you run a master. For those of you that will be doing the training, we'll talk more about high availability and multi-master. For now, since I have only so much slide real estate, we'll just run one. And then we'll run slaves, Mesos slaves on the rest of the boxes to help to do all this coordination. Now, these are two different logos here, but they're the same logo, just with slightly different colors. I'm just trying to differentiate the masters and the slaves. Okay. So step 3 in this process is we're actually going to now run our frameworks. But to the frameworks, the illusion is we're just back to this big pool of resources. So for Hadoop, to run Hadoop, Hadoop communicates directly with the Mesos mastery, with this kernel layer, Under the covers, that communication then becomes Mesos sending messages, scheduling the tasks other places, and actually launching Hadoop across the data center. It's the same thing is true with Spark. Spark communicates directly with Mesos. The illusion is this big pool of resources, this data center computer. Spark communicates with the master. Master then launches and executes the resources. Okay. And then finally, you can imagine the same thing happens with Storm. Alrighty. Step 4, profit. The good stuff. So what's the good stuff? Well, again, thinking about this as just one big pool of resources, we can start to actually utilize single machines more fully. That is to say that while this picture makes it look like we're only running a single Hadoop or Storm or Spark per box, most boxes these days have tens of cores, lots of RAM. The standard box at Twitter is about 24 cores, 72 gigabytes of RAM. You can't actually utilize those entire boxes in many cases, so you might as well run multiple things on the same box, increase utilization even more. Again, since we're just treating this like one big pool of resources, this is agnostic to the frameworks themselves. The frameworks are just running tasks, processes. So it's very easy to introduce this. And we can do this with all sorts of different frameworks to actually increase the utilization on our boxes by running multiple things in the same box. This increases node diversity as well, better for failures. We'll get into that in a second. Okay. Next, we can benefit from statistical multiplexing. So getting back to what I was talking about earlier, when Hadoop might finish running some things and there's idle resources, we can go ahead and we can launch Spark there if Spark has jobs to run. So getting back to this picture, again, there's opportunities here to go from something that looks like what you see on the left to now what you see on the right. This reduces CapEx and OpEx because we're more fully utilizing our clusters. But it also can dramatically reduce latency. You're giving something that you previously, via static partitioning, gave only 33% of the cluster to, the opportunity to now possibly use close to 100% of the cluster. Your software can run faster, you can reduce latency, get better performance. This is actually a graphic showing a pretty big cluster, probably about 100 machines, running a mix of Spark, Hadoop, and MPI. And what this shows is the share of CPU resources that have been allocated to the different frameworks that the frameworks are using over time. So a couple things I want to call out here is, at this point in time, Hadoop is actually able to use close to 80% of the cluster, more than 80% of the cluster. But later, when all the tasks actually want to run, it's like we statically partitioned the cluster in 4 ways, and each one gets roughly 25% of the resources. Now, if we had a lot more time in this talk, we could talk about all the other intricacies of Mesos, a lot of the features that have been built for supporting more things, such as maybe you don't just want 25, 25, 25, you want certain percentages, reservations, and quota. We're not going to get into that in this talk, but feel free to please come talk to me afterwards or during the training, ask more questions about that stuff. Okay. Okay, failures. So, of course, failures happen. But the nice thing now when failures actually occur is, without actually having a human go in and do anything, processes can get rescheduled across different places in the cluster. Okay? All right, great. So this sounds pretty good. What else can we actually do? So other than Hadoop, Spark, and Storm, what are some of the other things that we can actually run on Mesos? So there's a bunch of current frameworks that exist that have already been ported to run on Mesos. Hadoop Spark, dpark, which is a clone of Spark, but just straight in Python. Storm, which you've probably many of you have heard of, Chronos, which I'll briefly chat about, MPI, and Aurora, which I'm also going to briefly talk about. Okay. So what about XYZ? What about some other framework that wasn't actually in that list? Well, there's a couple options. XYZ may be something that you've never even built. It may be something that's already built and is running at your company as a distributed system. So the first thing you can do, if you've already got a system running and you want to run it on Mesos, is you can port an existing framework or system to run directly on Mesos. So what's this kind of look like? Well, if you don't want to get too in the weeds of the actual distributed system itself, a typical strategy is to more or less write a wrapper which acts as that application layer which communicates with Mesos and kind of launches the existing distributed systems components directly on Mesos. To write a wrapper, you're looking at something like 100 lines of code. The more involved that you write the wrapper to be, the more you can take advantage of features like elasticity, other things that Mesos provides to make the framework feel like a more native framework in Mesos and not just like you've launched something 10 times that's running. You can take a look at source examples in the Mesos repository to get an idea of what it takes to actually write one of these frameworks or port an existing framework. You can also look at MPI in the repository as well. You can also write a new framework. So why might you want to write a new framework? Well, there's lots of reasons. There's new frameworks coming out every day, better ways that we're figuring out how we might want to do data analytics or run other things in our data centers. So the reason why Mesos becomes attractive for writing a new framework is because as a kernel, Mesos really starts to provide a lot of the primitives that make writing and obviously running a framework much, much easier. So when I say primitives here, what I'm really referring to is Mesos provides this kernel layer, which is sort of an extracted commonality, abstractions across a bunch of existing distributed systems. It's sort of like looking at a bunch of distributed systems and saying, what does every distributed system need to do? Wouldn't it be nice if there was a layer where I could write my next distributed system which can leverage those things, and those things all come for free? Unfortunately, until systems like Mesos and other exist, pretty much every new distributed system that gets written re-implements a lot of the same stuff. Launching tasks, monitoring the tasks, failure detection, so forth and so on. And we shouldn't have to re-implement them each time. So one of the big goals of Mesos is to actually provide that layer such that people like you can write new frameworks in the future much, much more easily. So a case study of this is a framework called Chronos. And this ties into different frameworks that you might actually want to run on your Mesos cluster. So what is Chronos? Chronos is distributed cron with dependencies. So I'm going to jump to, okay, sorry. There's a bit of a, this is not my laptop. I was going to be showing a demo, but since we're doing this without my laptop, instead I'm going to jump to some other slides that can show some stuff on Chronos. Just a sec, bear with me. Oops, this is also reverse scrolling. Okay. All right, so it's just distributed cron with dependencies. So this was built at Airbnb, and this is actually the web UI for it. It's a system that runs on Mesos, which has a pretty nice web UI, which I think is in some cases an anomaly in our community. Okay, so before Chronos at Airbnb, they had a single cron machine. They had a single cron machine that was running, and that cron did a whole bunch of the work in their data analytics to kind of tie together a lot of the pieces that needed to get done to do the work that they wanted to do, right? So this cron was pretty gnarly. You can't read this. It's not intended to be read. It's more intended to show a small snippet of a cron tab that existed in that cron. which is all the different tasks that they might want to do for cron. All right, so what are some of the issues here? Well, it's a single point of failure. This was running on EC2, and this was failing fairly often. And all the jobs actually ran on that box, so it was resource starved. So even though we could actually farm these jobs out and run them in a distributed and parallel way, this just wasn't happening. I keep saying we, but I didn't build this, or nor do I run it. This is all the Airbnb guys. Okay, so the Airbnb guys stepped back and they said, all right, we really want to build something that can do kind of distributed cron. We want it to be fault tolerant. We want it to be distributed. It'll actually take advantage of resources. We want to make sure that it does retries when failures do occur. Eventually, the cron tasks succeed. And this last part, which I think is really, really great, is we want to tie in the dependencies. One thing that you can't really see here is some of these tasks have dependencies with one another. And to actually capture that, they used all sorts of crazy things like, oh, we'll schedule that job after the other one and put a sleep statement in to make sure that the previous job is finished because we think that the previous job is going to take n seconds. So when this one runs, we'll sleep for n seconds, and then it should be finished, and we'll go from there. So there's a lot of dependencies, and they wanted to be able to actually capture that. So just a sec. Now switching back. Okay, oops. Chronos. Okay. So they ended up building Chronos. They wrote in about 3,000 lines of Scala, which is pretty impressive when you consider everything that it's actually doing. It's a distributed, highly available, and fault-tolerant framework, and it never opens a socket. It's a distributed system that actually never opened a socket because it was built on top of Mesos. It leveraged those primitives to actually do what it needed to do. Okay. All right, so some of you might be thinking, well, if Mesos can kind of give me this abstraction of something like a data center computer, can I run stuff other than analytics? And the answer is definitely. In fact, one of the frameworks that I'm not going to talk about in too much detail, but just a little bit, is this framework Aurora, which was built at Twitter. The basic tagline for Aurora was, let's run n instances. I want you to run n instances of my server just somewhere forever. So in this case, server really means some arbitrary command line, some program, some jar, whatever it is. This was developed at Twitter, and it currently runs on hundreds of production services. It currently runs these services, including ads. It was also recently proposed for the Apache incubator. So what does Aurora look like? Well, it's yet one more framework, one more application on top. I'm going to use the Twitter bird here to resemble the logo, since it also doesn't have a logo just yet. But with this framework now that I'm just running some instances of some command line, it enables us to start running things like Ruby, Java request response services, and Scala right alongside your analytics infrastructure. Okay, so some of you might be thinking, okay, but hold on a second, what about resource isolation? I definitely don't want my end users to have to wait for our website because my Ruby process ended up running on the same machines as some analytics, and there was resource contention. So Mesos actually provides mechanisms for doing resource isolation. If you're using Linux, you can use something called Linux control groups. This provides an upper and a lower bound of CPU. So you can make sure that a process never uses more than some CPU and is guaranteed to at least be allocated some specific amount of CPU. We can also do memory limiting. Network I/O can be done by the traffic controller. We can actually shape the amount of bandwidth in and out for your applications. We're currently in progress. We're adding file system isolation, so you only get so much of the file system. Disk I/O and disk is some of the other stuff we're adding as well. All right, so this talk was really just supposed to be a high-level overview, jumping you into what Mesos is, how Mesos can help you solve some of your problems. Data center management is really a pain. Mesos makes running frameworks on your data center a lot easier. It also helps increase utilization. You can get reduced latencies for a lot of your jobs, higher performance, while reducing CapEx and OpEx. And a really interesting one is, rather than build your next distributed system from scratch, you might consider building your next distributed system directly from Mesos, because it makes it much easier. You can use the Mesos primitives. You can get a lot of other stuff for free. And the nice thing about that is then after you've launched your system with Mesos, if you want to then go and run some other system, it's relatively easy. You can just launch that system alongside yours in a Mesos cluster and keep running. Finally, you can really start to share your data center between analytics and online services. I mentioned that the Aurora framework from Twitter, it's running on thousands of machines in multiple data centers. Your tweets today are likely going through some code path that goes on a Mesos machine where there's other services running as well, some analytics. Okay, so there's going to be training for Mesos tomorrow afternoon, and it's going to kind of walk through what it looks like to actually run a Mesos cluster, launch frameworks, run things like Hadoop and Spark, deal with failures, deal with high availability, a lot of these other features. During that session, I just wanted to call out one person. The TA for that session is going to be Paco Nathan, who's sitting in the back. He can also help to answer lots of questions on Mesos that you guys may have over the course of today. You can just come find us during the breaks, and we'll chat about that. And I would love to, at that point, open it up for some questions. Yes?
I had seen earlier that that Mesos used Linux containers. Is that no longer true? I didn't see that mentioned in the slides anymore.
Yeah, so Linux uses control groups. So Linux containers LXC is a layer of abstraction on top of control groups. So the underlying fundamental means that LXC containers is getting isolation is through control groups. Mesos directly uses control groups. We at one point did use LXC, probably upwards of 2 years ago now. LXC has gotten a lot more growth in the community since those 2 years, but at the point that we decided to do it, the real value of LXC wasn't there. We could get pretty much everything we needed directly by interfacing with the containers themselves. So it still uses containers. It still uses the isolation mechanisms of LXC just directly.
Got it. Thank you.
How easy is it if you already have a cluster up and running, how easy is it to migrate to Mesos? Is there any learning that you can tell us?
Yeah. So when you say you already have a cluster up and running, you mean of Hadoop, of Spark? Sure. Okay, so if you already have a cluster up and running of Hadoop, you're usually still going to run HDFS on all of those machines, so you kind of don't do too much. You keep Hadoop, except you only launch HDFS. You keep Hadoop installed on all the boxes, except you only launch HDFS. Then, as I mentioned in those steps, you install Mesos on all the boxes, you bring up Mesos. That's a really straightforward process. The training tomorrow will actually go through what it looks like to be manipulating the Mesos masters and slaves. The next step is, rather than go and install something like Hadoop or Spark, the package, on all the machines, this is ignoring the fact that it's already installed for HDFS, but rather than going and installing those things on all the machines again, you install those in your file system being HDFS. So you put those there such that when you then run Spark or Hadoop and have it connect to Mesos, when it goes to run on any of the individual machines, it pulls down the necessary resources it needs to run that Hadoop task tracker or that Spark worker. Okay? There's a couple really nice benefits of this. First, it's pretty idempotent. It does the same thing every time. You don't have to do any sort of installation. Second, you can start running multiple versions of Hadoop at the same time. You can go ahead and you can install, you can be running Cloudera 3U5. Maybe you're ready to upgrade to 4.21. You can keep running Cloudera 3U5. You can stick the new Cloudera 4.21 distribution into your HDFS, launch another job tracker, which is for Cloudera 4.21, have it connect with Mesos, and now you're running 2 Hadoop instances on the same cluster, sharing resources at the same time. I didn't talk about that in my talk, but it gives you a lot of value, especially as you're starting to migrate from one Hadoop version to another version. In fact, you can try out new Hadoop versions. You can do all sorts of stuff like that. So it's a pretty painless process. Hope that answered the question, sort of? Yeah, okay, great.
What is the added machine-to-machine latency and overhead? So for example, if I wanted to port like a 0MQ based RPC system to just an application on top of Mesos, what kind of overhead would I be looking at?
Great. So the scheduling itself is fast. I think when the Spark guys had actually done some performance tests on scheduling tasks elastically through Mesos itself, it was on the order of between 5 and 10 milliseconds or something like that of extra latency to schedule the task. So that's pretty fast. It's likely the case that if you're already running a distributed RPC system, a lot of the network communication is going to be out of band of Mesos anyway. So other than the actual coordination and scheduling of the processes onto Mesos, which you do by writing what's called a scheduler, all that communication is going to be out of band. It's going to, be its normal performance. So the real question you'd then be asking is, well, what types of implications do I have from possibly running on machines with other things, including doing things like analytics? And the big answer there is, well, we're highly leveraging things like Linux control groups to mitigate those resource isolation issues. And that works fairly well. We run a lot of these at Twitter running real production services, and they provide most of the value we need. There are occasional glitches where, we needed to set the resource constraints a little bit differently, but the nice thing about that is we're doing that, the Mesos code base is doing that, you don't have to worry about that, you're just actually launching your applications. For any of you that are running in the cloud today, if you are running on bare metal with Mesos with multiple things on the same box, I can guarantee you'll get better performance than when you're running in virtual machines in the cloud with other contenders. Resource isolation via control groups has much more insight into your applications and what they're doing and can do much, much better resource isolation.
Can you run Mesos on top of other job schedulers like Slurm and Torque?
Yeah, you sure could. Yep, it's turtles all the way down. I mean, people often run Mesos on EC2. So what's the value at the end of the day? When I said your data center before, and I showed those machines, yeah, for the most part, I'm talking about a physical data center, but that could just be a bunch of virtual machines. So why is Mesos, again, valuable in this type of situation? Well, a lot of people, including Airbnb, they're a great company to talk to about this. You buy a pretty standard size VM, say from AWS, 8 cores, 8 gigs. Then you launch your service on that 8-core, 8-gig machine. At the end of the day, you're paying for 8 cores, 8 gigs, even if your service is still only using 1 core or 1 gig. So running Mesos, even across your virtual machines, can help to increase the utilization of the virtual machines themselves, thus giving the value back to you, not the value to AWS, who's relying on the fact that you're going to buy an 8-core, 8-gig machine and use 1 core and only 1 gig. Sorry for the AWS people in the audience. But it's a business. It's a good business.
I have a question about security. Have you given any thought about issues like authentication or tracking who has made requests or allocation of resources, and also preventing unauthorized scheduling of jobs, et cetera?
Yep, that's a great question. This summer, Mesos participated in the Google Summer of Code, and we had somebody working exactly on the security and authentication questions. We've made some good progress. The goal is in the next release of Mesos to have that stuff all wrapped up so people can take advantage of it. Now, aside from the security and authentication issues themselves, we do have some mechanisms for limiting the amount of resources that any particular scheduler can get. So that can mitigate a lot of the issues. You can launch experimental schedulers or an experimental Hadoop or something else like that and not be worried that it's just going to fork bomb your cluster, right? So that can happen. And again, with the analogy being this is just one big data center computer, we have to protect against that kind of stuff. And so we have those mechanisms in place.
All right, last question, and then we'll break.
How do you compare Mesos versus Apache Yarn?
I love this question. So I'll just repeat it in case nobody heard it. How can we compare and contrast Mesos versus Yarn? Yes? That was the question? Yeah. Okay, so there's a couple things to call out. First and foremost, just a technology difference. Mesos is written in C++. Mesos provides, because it's written in C++, because it's a native app, it provides that kernel interface in a bunch of different languages. Python for the JVM, for C++. There's guys in the community that created Go bindings. There's guys in the community that created Ruby bindings. Because it provides that native interface, it's pretty easy to start building a whole bunch of apps on top without having to go through the JVM. It's written in C++, okay. Next is probably an architectural difference. And this is probably the trickiest difference. Mesos and Yarn, maybe I'll try to answer this question with a picture. The tasks that actually get launched on Mesos and Yarn can dynamically adjust the resources, the container, if you will. You can dynamically adjust the resources per container in Mesos. That is to say, in Mesos, we have this notion of what's called an executor. If you were to be writing a framework, you'd find all about that. An executor runs one or more tasks. Think of this like the threads of your distributed system. The executor's resources can change over time. So in Yarn, you typically launch a single container with a fixed size. You run your stuff within that. In Mesos, you can launch a container and it can grow and shrink over time. So in summary, what that really gives you, it gives you elasticity on a per node basis as well as across the cluster. Some applications take advantage of that a lot, like Spark. Other applications can take advantage of that, like old Hadoop. Some applications can't take advantage of that, but it's a pretty fundamental difference, and it's what makes running something like Spark and Mesos work really, really well. You can do better resource sharing because things change elastically even on a per node basis. And the last thing to mention about comparing and contrasting Spark and Yarn, Yarn and Mesos. Mesos has been running in production at Twitter for a couple years. It runs on thousands of machines. It runs a lot of Twitter's critical services. We spent a lot of time working on scalability, performance, robustness, and we run things that are not just analytics, but things that when stuff fails have SLAs where we need to make sure that we're relaunching those things as quickly as possible. That's one of the other big. Now, of course, there's a laundry list of features that are different. If you'd like to know what some of those are, I'd love to chat with you about it. I love talking about this stuff. It's an interesting part of the community. Cool.
Right. Thanks, Ben.
Yep.
Ben did an amazing demo at last year's AMP Camp that I don't think he was able to do today because we are only able to present from one laptop. But you should go watch the video from it. Basically, he killed one of the Mesos masters on their production server. But first, he made sure to show everybody that there were ad services running on Mesos at the time. And even a year ago, Mesos was already, Ben was confident enough in Mesos that he was willing to risk probably a major portion of his job on that demo.
Yeah, yeah. Go watch the demo.
I hear he still does this.
It's kind of a party
after
trick.
a few drinks with friends. Just kidding. Twitter.
Great.
So we're about to take a 15-minute break now. We will see you back here for the next session, which covers the Spark universe, Spark streaming, and Shark. And then after that, lunch, and following that, the hands-on exercises.